Hello guys, it's your guy Vierra. Welcome back to my new tutorial. So guys, in this tutorial we are going to be generating the M and G code required for VMS project 7. So guys, let's get started. We are going to come under solid cam turning, new, meter, save. Okay, so we are working with millimeter. I just want to work this time with external. I'm going to browse directory, desktop. I'm going to create a new folder. I'm going to VMS. Okay, so I'm going to take my path name as VMS project 7. Go for the green check, coordinate system, making sure that you are working with center of revolution face. Select face. I'm going to select this face. Okay, let's determine the largest diameter in the path. So the largest diameter is actually 70 millimeter. So I'm going to take 80 millimeter. So right now we want to define the stock. So we're going to take 80 millimeter for the extra raw material. Okay, insert, new path. I'm going to select the surface. Just come over here, normal, circle, 80 mm. Okay, feature, extrude base. I'm going to use the option offset from surface. I'm going to take the surface. Now, for the clamping, I'm going to insert 20 mm. Let's see. Reverse offset. Okay, this is fine. Direction 2 mm. Go for the green check. Stop assembly, right click on the diagram and then select change appearance. Okay, fine. So what you want to do here is come under stock, right click, define, select 3D model, cut selection. I'm going to select this, resume, show. Okay, we are all good. Next, target, define, show. Okay, target properly done. Now, in case your target isn't properly done, just delete this, unselect, and then select back your cut model, show. Okay, we are all good. Go for the green check. So guys, the next thing we want to define is our jaws, the fixtures. Setup, right click, edit. I'm gonna open machine preview. So currently guys, this is actually our piece currently. It's seated at this point. Now, fixture right, clamping fixture. I'm gonna edit it. Scroll down. Now, I think I'm pretty good with the parameters of my jaw. Show clamping. So this is the way it's going to look. Okay guys, this is our clamping. Go for the green check. Okay, so as you notice, 1 2 3 4. Now, table post. Now, as you notice, the clamping is actually in front, right? We want to make sure that those clamping goes behind. So I'm gonna take pick Z, and then I'm gonna select this point. So it's at -100, right? I want a clamping to actually be at this point, but it doesn't mean that the clamping should be at the end. So it should actually hold from here. So I want to go -96 rather. Okay. So as you notice, it's actually holding. Go for the green check. So guys, we are done with the machine setup, the coordinate system, stock definition, target definition, and we are done setting up our clamping fixtures. So the next thing we are going to do is the operations. Come under solid cam turning, facing operation, our face operation. By using solid, I come new. So which face do I want to face? I want to face this face. Where do I want to end? At the same point, so this face. I want to make sure that I am facing from upward to the center. I change this to clockwise. So right now I'm facing from upward to center. Hope you got that. I'm going to cancel this. I'm going to select wireframe, new. So how do wireframe works? So with wireframe, this is the face you are selecting, right? So this face is allocated to this line, as well as this other part is allocated to this other line. Just look the way it goes. So you have to follow this, okay? Make sure you follow this. Okay, all fine. Which wire is allocated to this face? This is the wire, so I select this wire. I go for the green check. Okay, modify geometry. Okay, so looking upon the wire, guys, this wire seems to be going from upward, from center rather to upward. So what I'm gonna do is right click, I'm gonna reverse. So right now it's going from upward to center. Now you want to make sure that auto extend should be activated, and equally auto extend to end of stop activated too. Okay, all fine. Go for the green check. So with this, you should be able to select your geometry using wireframe or solid frame tool and extend arcing tool. So let me just go for the finishing. I'm going to use 35. Okay, all fine. Getting tool direction, it should be this. Oh, perfect. Levels, safety distance, I'm going to take 2. Technology, smooth, I'm going to take step up of 0.08, offset of 0.02, retreat value of 0.078. Finish. I'm going to on my compensation, link or fine, good, save, calculate. So guys, simulate turning. Let's look at this. Simulation done. So guys, what you want to do here is use SolidWorks Verify to ensure that there is no collision between the tool and the workpiece. Go for SolidWorks Verify. Simulate. Okay, so right now you are pretty sure that there is no collision between the tool and the workpiece. So for our next operation, we are going to make turning operation. I'm going to use solid. I actually turn this face. I'm going to use this surface and I'm going to turn onto this surface. So when you look at the arrow begins from this point to this end. So it's pretty good. So do not make it to go down. Okay, go for the green check. Tool. I'm going to use my same external arcing tool. To direction. Levels. I'm going to use safety distance of 2 mm. Fixture protection, I'm going to put 2 mm equally. Technology, I'm using rough. Make sure you are using long external as mode. When you come under the rough option, use rough type soft. Step down, I'm going to use a step down of 0.04. Now the retrieve value, you want to make it 0.078. Now I'm going to use distance of 0.02. Okay, semi-finish, I'm going to use no semi-finish, and my finish I'm going to use ISO turning method. Step over of 0.08 with a compensation. Link or fine, go for the simulation. Simulate. Okay guys, so as you notice, the tool actually descend. So this actually means that when you go to my turning tool parameters, it's definitely sure that descending is actually activated. So you want to make sure that you deactivate descending and you choose non-descending. So when you choose non-descending, this part which is actually being performed will not be turned. So I'm gonna off descending and I'm gonna take non-descending. I'm gonna stop the simulation right now. So in order to machine this part and this portion, we are going to use grooving operation. So one thing, I will first of all edit this operation. Now I come under technology, strategy, and I take non-descending. Now sometimes you could also change your operation name, like this is turning operation, so I could include turning operation, and then I save. Now remember that we took non-descending, so you have to save, calculate one more time. So right now the tool isn't going to descend. As you notice, it goes straight. It's not going to try to descend. Okay, I'm just gonna off this. So I go for the grooving right now. So my groove begins from this point and it ends here. So you want to make sure that the arrow is in the correct direction. Oh, perfect. You go for the green check. Okay, tool. I'm going to select a groove tool here. I want to make sure that the holder is being removed. Okay. Groove direction. You want to make sure that the groove direction is upward, just this way. Levels. I'm going to take safety distance of 2. Technology, long external, roughing. I don't want any roughing pass. I'm just going to go for the finishing pass only. No semi-finish. ISO finish on the compensation. Save, calculate, simulate, turn in. Okay, so right now, as you notice, this groove is not being done. So this actually means our groove tool is big. So we are going actually to reduce our groove size. So close, tool, select. So over here, I'll put, let's say 4. I'm going to take the height to 14. The width, I'm going to reduce it to 2. This, I'm going to take it to 8. Go for the green check. Okay, simulate. So let's verify. Turn in. Okay, all perfect. Now the next thing we are going to focus is based on this hole. Then when we are done with this hole, we are going to make the slots. Then we are going to use cut off operation, and this project should be done. Okay, let's move on. So looking upon the holes, guys, now we got one hole over here and we got some smaller holes. So you want to understand that the hole at the center of the part will be done with solid cam turning drilling, but the holes that aren't at the center will be done with solid cam 2.5 drilling. That is actually the difference. Hope you got that. Okay, so I will just come under solid cam turning. Now when you check at the diameter is 50 mm. Okay, so last time I told you guys that you could actually drill a hole. When the hole is small, you will take exactly 50 mm, but when the hole is quite big, do not take 50 mm directly. What we do is we are going to take about, let's say, 40 mm drill, and we are going to use boring operation for a proper surface finish. So let's go for this. Drilling. When you are using solid cam turning, the drilling is always at the center. No coordinate system, or let's say no geometry has to be selected. Turning, I just go for the tool, select. I'm gonna use spark drill. This time around, I'm gonna use 40 mm. I wanna increase the length to 100. Okay. So direction already selected. Levels. Or fine. I'm gonna take 2 safety distance. Technology. Drilling start. This is the start. Oh, perfect. Drilling end. Okay, or fine. Cutting tape should be activated. Link or fine. Go for the simulation. Simulate. Turn in. Go. Okay, so the drilling has been done. So this extra part will actually be removed using our boring operation. So let's go for boring. Okay guys, so in order to do boring operation, we are still going to use turning. So we go for turning. I'm gonna take solid geometry. Now where do we want to do the boring? It's in this inner part, so I select it, and again I still select the same part. Now you notice that the arrow begins from this part to this part, but this is not the right direction. So you want to reverse this direction such that it begins from here to here. Oh, perfect. Go for the green check. Or tool. The tool used for boring is known as internal turning, because you are making turning, but you are making internally. So we use internal turning. I'm just gonna remove this holder and equally this. Okay, go for the green check. Direction. So this is the actual direction you have to make. If you use this, there's going to be accident. So this is the actual direction. Levels or fine. Technology. Now when you are making boring operation, you use long internal. You use long internal because it is an internal operation. Roughing. I'm just gonna go for a finishing only. Okay, step over 0.08, compensation on, strategy, non-descending, we are all good here. Save, calculate, simulate, bending. Okay guys, boring operation totally done. Okay guys, so our next operation will be about these smaller holes. One thing you should note here is the larger hole is at the center, so we use solid cam turning, right? Since the hole isn't at the center, we are going to use solid cam 2.5D. We come under solid cam 2.5D. You could either use drilling operation or drilling recognition. Okay, I go for the drilling recognition. So I'm going to select geometry. I'm going to select, I come to find hole. Okay, so if you are actually understanding this, you come to understand that shape 1 will indicate this smaller hole and shape 2 or group 2 indicates the larger hole. However, the larger hole has already been drilled, right? So what I'm gonna do is I'm gonna delete it. I right click and I removed. Okay, so we are left only with this smaller hole. You go for the drill. Okay, so the tool, I'm gonna put this down. I'm gonna measure the diameter of my smaller holes. So the diameter indicates 2 mm. So I put this back up. So I'm using a spark drill of 2 mm with a length. I'm gonna increase this length to 100. I go for the green check, levels of fine. Now I'm gonna edit this level, depth type. You wanna make sure that full diameter should be selected. You apply to all and you go for the green tick. Okay, or fine, save, calculate. Okay, simulate. Now this particular hole is a milling operation, so you go for solid, verify. Okay, or fine, rest material. Okay, so the hole is properly done, achieved. Okay, I'm just gonna untick this. So for the slot guys, we are going to use a profile operation. So remember that slot equally is a milling operation and not a turning operation, right? So you go for profile, geometry. I'm gonna select this geometry. Okay, or fine. Now there's one thing I missed. Okay, now when you are looking upon this geometry guys, you notice that we got, let me just rotate it this way. So we got Z and we got X, right? So but when you are dealing with milling operation, the Z is always pointing up. So you have to define a new coordinate system. So come under coordinate system, add coordinate system, mark 1 position 2. Okay, I scroll down. You select coordinate system and then select face. Just come over here, select this face. Okay, so here is the coordinate system. I want to make sure that Z looks upward. So I'm going to flip, let's say flip X and Y together. Let me see this. No, you need to play with this until X. Yeah, so Z is looking up. Okay, so now X has to look the other side, so I'll flip Z. Okay, I'm all fine. So Z upward, X the other side. You go for the green check. Okay, accept. Now new geometry. I want to select this. Okay, go for the green check. My tool, I'm going to be using a small end mill. An end mill. I'm good with this end mill actually. I'm just going to put 100 mm. Okay, fine. Link, upper level. Now for the upper level, you want to select this point to be accurate. Okay, pocket depth. I'm gonna rotate this. I'm gonna select this point. If you select the line, you notice that it doesn't become green, so there's no high accuracy. I want to select this point. Oh, perfect. So for the data value, I'm gonna go minus, let's say minus 0.2. Okay, technology, geometry. let's go right, because if we are going left, collision. So let's go right, go for the green check. Now I'm gonna take offsets 0.02, 0.02, maximum step down of 0.04. okay, or fine link. I'm gonna take normal of 0.01, same as slid in. Okay, save, calculate. Okay, so as you notice, mark one position to simulate, solid verify. Okay, so we are done here. So I'm gonna take rest material. Okay, so properly done, guys. So the extra line, it's actually the chamfer. Okay, so we have to make chamfer equally. So actually there are 6 slots. I'm going to use an operation known as transform. What the transform operation does is it actually revolves this particular operation to obtain the remaining slots. Rather of making the slots one by one, I'm going to use transform operation over here. Transform. I'm going to take 4 arcs. So I'm going to include the origin angle of transform. Actually there are 6 slots revolving, right? So 360. So 360 divided by 6, I obtain 6. Now, the number of slots are 5. I'm gonna insert. So 1, 2, 3, 4, 5, 6. We are good. I go for the green check. I save. I simulate one more time. Solid verify. Play. Slot 1 done. Slot 2 done, slot 3, slot 4, slot 5. Okay, oh perfect. So we are done here. For the chamfer, guys, we are still going to use profile operation, geometry, this. Okay, fine. Go for the green check. Tool. I'm gonna use a chamfer tool. Chamfer mill, just making sure the length is 100. Okay, go for the green check. Levels, upper level. My upper level should be this point, and my depth should be this other point. Go for the okay. Technology, geometry, stick right. Thing left should be fine. Okay. I'm gonna put some offsets. .04. Oh, perfect. Link. I'm gonna take normal. Something technology. Under technology, making sure that you are using chamfer. Now the cutting diameter it looks big, 0.02. Okay. Seeing we are good here. Link normal. 0.01, same as slid in. Okay, or fine. Save, calculate, simulate, verify. Now we got an issue. When you look at the chamfer, you notice that this end is actually bigger than this end, whereas a chamfer needs to be uniform, right? So in order to repair this, you want to come under geometry. Select geometry. Now geometry type. Now actually by default it's always selected flat. The geometry type is always selected flat. You want to use wrapped and select back the geometry. Okay, I'm gonna be fast tool, fine. Upper level, just gonna check this point. Lower level, this point, or fine. Link, or fine. Save, calculate, simulate, solid verify. Okay, or fine. So as you notice right now, it's totally uniform. Remember that the chamfer, it's actually throughout the whole slots, the 6 slots. So use again transform. 4 axis, include origin, 60 degree. I'm gonna take 5, I'm gonna insert. I go for OK, and I save. Simulate, so they verify, play.